Hi Year 12. Today's video is going to have a look at 1E, adding up the terms of a sequence and bring in the symbol for sigma, which we'll have a look at a little bit further down. So for any sequence, T1, T2 and T3, etc., we define S of n, with S is the sum, as the sum of the first n terms. So the sum of a sequence that goes up to n terms would be written as S sub n, or sum to n of all our terms added up. So term 1, term 2, term 3, all the way up to term n. S of n is also called the nth partial sum. So we could sum our terms at any point along in this sequence. So we could find the sum to 3 terms, for example, or the sum to 8 terms. A sequence of the values S1, S2, S3 is called the sequence of partial sums, and it's also known as a series. Okay. These next two little points that I've got in purple are really important. And it says the original sequence Tn can be recovered from the sequence S of n of partial sums by taking successive differences. So what we can say is if we had a sequence that was full of different terms, the first term, T1, would be the same as our sum to 1, because there's only one term in there, so we're only summing one thing up. If we wanted to find any particular term along the way, we would say that we'd look at the sum to that many terms and take away the sum of the term before it, and we could get that term. And we've done that below in this little table. So what we've got typed in there is our n values, which would be the position along the sequence, and our S of n, so the sum along that sequence. So the first term, which is also the sum to 1, is equal. Okay, they're both equal to 1. Our second sum is 5, and that's found by adding our first two terms together. So if we get this sum of 5 and we take away the previous sum, we're going to get the term that matches up with that sum. So 5 minus 1 is 4. And likewise, the sum to 3, take away the sum to 2, would give us our term 3. And that would give us 7. And we can do that along each of our different positions to get our term value. What you might notice is after a few of them, we can actually work out the pattern, and we're actually adding on 3. So in this case, this is an AP, our terms here. Let's have a look at the next part, which talks about sigma notation. Now, you might have seen the symbol sigma before. Sigma is this symbol here. It's a Greek letter in the alphabet, and it's called sigma, as in S-I-G-M-A. And it is basically used to represent addition, or I call it the sum of. So we're summing things together. And we're going to have a look at summing things together down below here. Now, in this case, we've got T1, T2, and T3 making up a sequence, so lots of terms here. And we can work out what the addition of the 5th to the 20th terms are, and we can write it in terms of sigma. So we've got our sigma symbol here, and down the bottom and the top we've got values. So we're saying that we're going to sum from n equals 5 to n equals 20. We just don't pop the n equals on the top. And we're going to sum from 5 to 20 all our terms. So I'm popping 5 in where there's an n. I've got term 5, and I'm going to add to that my next n value. Term 6, term 7, etc. all up to our final term, which is term 20. And here's a couple more examples below. We're summing from 2 to 5 of n squared. So the first term would be 2 squared, and we'd be adding each successive n value until we hit 5 squared. And then we just calculate that on our calculators to get 54. Similarly, we do the same over here in the other series, but we're going to start at n equals 6 and go to 10. So we're always wanting to look at the values that are around our sigma. Now down below, I've got two examples here. The first example being 2a, and we're going to evaluate these sums. So it's saying sum this sequence here, 5n plus 1, from 4 to 7. So our first thing is going to be 5 times 4 plus 1, which we've popped in there, and it's 21. Then we're going to pop 5 in, 5 times 5 plus 1. It's in here, it's 26. And we're going to do that for 6 and 7 and add them together so we get 114. Similarly, we're going to do the same over here. We're summing minus 2 all to the power of n from n equals 1 to n equals 5. So what you'll notice here is it's written next to the sigma, where above, up here, we had it up and a below of the sigma sign, but it means the same thing. So 1 goes in first. We're just having to be really careful because there's a minus sign in there, and we need to make sure that we pop brackets around that when we're popping it in our calculator to get our values from 1 all the way up to 5. What you'll find is because we've got changing powers between odd and even numbers, we're going to get our sequence changing between minus and plus as we move along. And if you've got, if you're an extension student, you would have seen that in extension as well. So just be careful because you're going to end up with a negative number for that sum, and that's correct. It just looks a little bit strange sometimes to be thinking that the sum of the numbers is going to be negative. That will allow you to now go and have a look at the exercises. Some of the earlier ones are quite simple, so make sure you push through to some of the harder ones in 1E.